In this video, we will discuss Bellmanford algorithm. So coming to Bellmanford algorithm, it is a single source shortest path algorithm. So single source shortest path means here we can see one example problem. So here it is a graph. It is having 7 nodes, 7 vertices it's having. So this 7 vertices, this is one is a source vertex. From the source vertex we have to calculate the distance to all the remaining vertices. So from 1 to 2 shortest path, 1 to 5 shortest path, 1 to 3, 1 to 7, 1 to 4, 1 to 6. So from single source to all the remaining vertices we have to calculate the distance. That is meant by single source shortest path problems. So here in Bellmanford algorithm, similar algorithm we have already learned for single source shortest path, which is Dijistra's algorithm. Dijistra's algorithm, but it won't allow negative edge weights. But here the edge weights can be negative. But one constraint is the graph should not have negative weight cycle. A cycle of resulting weight is a negative value. It should not have, such graphs cannot be solved by Bellmanford algorithm. Now coming to the algorithm, we can see the distance LU be the length of the shortest path from the source vertex V to vertex U under the constraint that the shortest path contains at most L edges. So here I have written distance LU, that is the length of the shortest path from source vertex is V, from source vertex to the vertex U. Be the length of the shortest path from the source vertex V to vertex U. One constraint is that the shortest path contains at most L edges. Shortest path will have maximum L edges. So distance of U means distance from the source vertex. So it is written as cost VU. Where there are no negative cycles, the shortest path will have maximum n-1 edges. Since it is an n-vertex graph, maximum number of edges will be n-1. So here now we can see this graph. So in this graph, this V is the source vertex and U is any other vertex. So from source vertex V, we have to find the distance to the one of the vertices U using K edges. Using K edges, this shortest path has, suppose it has K edges. So using dynamic programming approach, this can be divided into K-1 edges and 1 edge. K-1 edges from to an intermediate node J, and from J to U 1 edge is there. So the shortest path from V to U is divided into shortest path from V to J and from J to U. So from V to J means it is distance using K-1 edges. Here it is using the distance J to U. So this distance should be minimum. So this can be expressed using a recurrence formula. So that recurrence formula is this one, distance KU. So here this recurrence formula, distance KU. Distance KU means what? Distance U means distance from the source vertex V to U using K edges. That is equal to minimum among this value. That is minimum of distance K-1 U. K-1 U means what? From distance K-1 U, that means distance from source S to U using K-1 edges. That is comma minimum of this one, distance k minus 1 I plus cost of I to u, where I is an intermediate vertex. So distance from source to an intermediate vertex plus from that intermediate vertex to u. So that is represented in this figure, that is this distance. If it is the intermediate node is represented as I, that means the distance is from V to the minimum distance we have to take. So that is represented using this recurrence formula. Minimum of this distance k minus 1 u is the current distance. Whichever is minimum we have to calculate. Current distance, comma, distance of minimum of distance of k minus 1 I plus cost I to u. So using this recurrence formula we can calculate the shortest path distance from source node V to u. Now we can see the problem. Find the shortest path for the following graph. So graph is given here, which is having 7 vertices, and each edge weights also given. And the source vertex that will be mentioned in the question, the source vertex here is 1. 1 is the source vertex. So from 1 to all the remaining vertices we have to find out the distance using the recurrence formula. So here we will be using this same recurrence formula. This is used for finding the shortest path. So for finding the shortest path, first thing for doing the problem, first thing is we have to draw the table. Draw this table. The table will be having, so here in this graph 7 vertices are there. So it will have 7 columns, 1 to 7, 7 columns will be there. And 7 vertices, n number of vertices means edges, n minus 1 edges, maximum n minus 1 edges. So k value will be 1 to n minus 1 means it is 1, 2, 3, 4, 5, and 7 vertices means 6, n minus 1 is 6. So till 6 the values will be there. So we will write down this. So this each row represents, so each row here represents different values of k, and each column represents distance 1 to 7 using k edges. Using k edges, distance of each node, each vertex using k edges. So now we can see how we will calculate the values in this table. So first thing what we have to do is, first thing, 1, see here 1 is our source vertex. So from source vertex to, so first column, if you consider the first column, the meaning of the first column, what is the meaning of the first column? Distance of, so each column means this one, distance of k1. First column will be distance of, first column will be distance 1, 1. This is the first cell value, and this value is this one, distance of k value here it is 1. So distance 1, 1. What is the meaning? Distance from source to the node 1 using only one edge. Again the second, this element, second row first element, what is this one? Distance to this 1, distance to the node 1 using 2 edges. So whatever number of edges, distance to the first node is always 0 because it is a source node. So first column, that is a source column, we will fill the values with 0. Source column, all the values we will give it as 0. So that is the first step. So first we will draw one table with number of, how many number of vertices, that many number of columns will be there. Then we will draw the k value, row numbers, k values we will give to the row numbers. K means n minus 1, n minus 1 k values will be there, and the first column of the table, see the first column of the table, we will make those, put those values as 0 because 1 is a source node. From source nodes itself, the distance value will be 0. So now, so that cells we have filled, then next cells we will fill row wise. So first we will fill the values of the first row, then we will fill the values of the second row, then third row, like that we will fill till then after that we reach the last row. The last row contains the answer, that is last row. This 1 value means distance, this 0 value means distance from source to the first node. This 1 value means distance from source to the second node, that is 1. This 3 value means distance from source to the third node, that is 3. Then this value means distance from the source node to the fourth vertex 4, that is 5. So these are the minimum distances, we will get it as our answer. So how we will fill, we can see. So first we can start from here, filling of this value. So this value, what is the meaning here? Each cell means distance k 1 to 7. So here this row k value is 1. K value is 1 means number of edges 1. One edge distance. One edge distance, what is the value from the distance from the source node for each of the vertices that we have to fill here. So from one edge distance values we have to fill here, that is from the source node 1. So first here we will write, this is the column for the second node. This is a column for the second node. This is a column for the second node. This column for the, then this one is a column for the third node, like that it continues. So first we can see how we will fill the value, this value, how we will get this value. So this is obtained by one edge. Initially this first row we will fill like the direct distance from the source. Direct distance from the source. So source is 1. From source to the second node, what is the distance? From source 1. Source is 1 to the second node, the distance is 6. So that value I will fill here. Then this is for the third node. Third node from source to third node, node 3. What is the direct distance is? Direct distance is 5. So this is 5. So that value I have filled here. Then 4, node number 4 from source. What is the direct distance? That I can see from the graph. So this is node 4. Direct distance from source is 5. So that value I have written 5. That is directly connected edges will have the correct values. Other edges we will fill with other vertices. Distance to other vertices will be infinity. So next is 5. From 1 to 5 there is no one edge connection. Direct, it is not an adjacent node, so the value is infinity. Then 6 also there is no direct connection, so the value will be infinity. Then here 7 also no direct connection from 1, so that value also infinity. So like this we will fill the first row. So first row means each cell values means the distance, each cell value means the distance, this 1 to 7, distance k 1 to 7, k value is 1 here. So here we will write the direct distance in the first row. Next row onwards we have to calculate the minimum distance. So how we can see, so now row wise we will fill. So next we have to fill this value, the value 3. So how we will get that, this value we can find out. So for that we will use this equation. So now we have to next fill this value. Second row k value is 2. Here k value is 2. So we have to find out the distance to all the remaining vertices 2 to 7. So here first we will see this one. This distance k value is 2 here. So distance 2, then to first node 2, 3, 4, 5, 6, 7. So distance 2, 2, distance 2, 3, distance 2, 4, distance 2, 5, distance 2, 6, distance 2, 7. So those values fill this row. So first we can see how we will find out distance. The first, this cell value, that is distance 2, 2, how we are finding it out. Distance 2, 2. So this one, how we are calculating is minimum value we had to take from among the values. So this is current vertex, whatever we are doing the for vertex 2. So from the current vertex, its previous value, minimum value we have to take from a set of values. This set of values are its previous value, its previous distance value we had to take. So that is 6 here, previous distance value. Then we have to take the distances from all the remaining vertices. So we are doing for the vertex 2, the remaining vertices are 1, 3, 4, 5, 6, 7. From all the other 6 vertices, we have to write the distance values. So how we will write this distance value is, for each vertex, their previous value we will write plus distance to the current node. Like that we will write. So we can see for this example, for 2 the remaining vertices are 1, 3, 4, 5, 6, 7. So first the current value, the previous value of this one we have written, that is, now we are trying to fill this row, this cell. So previous value we have written here 6, comma, then now we have to write the distance from this, the node 1. Now we are doing for the node 2, so we have to write it for distance from 1. What is the distance from, previous distance of 1 is 0. So here 0 plus distance from 1 to this current node 2, distance from 1 to 2. What is that we have to take from the figure. So see the figure, what is the distance from 1 to 2? 1 to 2 distance is 6. So we'll write the value 6 here. So 0 plus 6. So now we have taken, we are writing for this cell, we have taken from the node 1, vertex 1 we have taken, vertex 2 already the previous value we have taken. Now we will write for vertex 3. So vertex 3, previous value we will write 5, that 5 is here, 5 plus distance to 3, distance from 3 to our current node 2. So this current node is 2, distance from 3 to 2, that we have to find out from the figure. Distance from 3 to 2, see the figure, 3 to 2, what is the distance? Minus 2 is the distance. So that minus 2 I have written here. So this is minus 2. So 5 plus minus 2. So now this I have taken from 3. Now current vertex is 2, taken from 3. Now I had to take the distance from 4 to our current vertex. So for writing this value, filling this cell, I have to consider the vertex. This vertex I had to consider, this value I had to consider, and from all the other vertices also, all the other vertices distance value I had to consider for writing. For all the other vertices value I had to consider for writing the value for filling the cell here. So now we can see, so here we have taken from the distance from the node 3. Now we can take the distance from node 4, 4 to 2. So 4, what is the previous value of 4? previous value of 4 is 5. So 5 plus, so that 5 I have written here, 5 plus 4 to 2. 4 to 2, what is the distance? That I have to find from the figure. 4 to 2, from the figure 4 to 2, from node 4 to node 2, there is no direct distance. So the value I have to write the value as infinity. So 5 plus infinity. Then 4 is over. Next I will take from 5. 5, what is the previous value here? It is infinity. I am filling this row, I am filling. So the previous value of the node 5 is infinity. So this value infinity means the total value, anyway if we add also, that value will be infinity. Then node 6 also the value is infinity, so I can write it as infinity. Here also 7 also infinity. Then I will write the minimum value from this. What is the minimum value among this? 6, 6, 5 minus 2 is 3, 5 plus infinity, infinity, other things are infinity, so the minimum value is 3. So that 3 I will write here. So I have filled one cell of this table. I have first row I have filled with direct values, first column I have filled with zeros. Then next I have filled this cell I have filled. Then I have to go for the next cell, that is 3. This value, how I get this 3 value, that I have to find. So now I have to fill this value. This cell I have to fill. So filling this cell means what? Again I had to, I will be using this equation, distance 2, 3, k value is 2, then to the vertex 3. Now my current vertex is 3. So this vertex, current vertex 3, so this position I have to fill. So while filling this position, first I will write the previous value. So previous value here it is 5. Previous value of that third vertex, just before in the this cell will get that value 5 I have put. Next thing what I have to do, now my current vertex is 3. The vertex 3's previous value I have written here. Then from all the remaining vertices, from 1, 2, 4, 5, 6, 7, also I have to write the values over here and find out the minimum. So first I will, after writing the previous distance of 3, then I will write from 1, the vertex 1. So from 3 I have written the value. So here this 5 I have written over here. The next values from the vertex 1 I have to write. So this is my current vertex 3. Now I have to, current vertex previous value I have written, that value is 5, comma. Next I have to write from the 1. 1, what is the previous value? Previous value means previous row I have to see. So previous row, that value is 0. So I have written 0 over here, plus from 1 to this 1 to 3, what is the distance? That I have to write. From 1 to 3, what is the distance? That I have to write. So here from the figure I can see that from 1 to 3 the distance is 5. 5 is the distance. So that 5 I will write here, 0 plus 5. So this is my current vertex. Vertex 1 I have, vertex 1 is over. Sorry, this is my current vertex 3. Now I have written for vertex 1. Now 2. From 2 I have to find out. From 2, what is the previous value? Previous row value is 2. The previous row value is 6. So here I will write 6 plus. Then from 2 to 3, what is the distance value? From the figure I have to find. 2 to 3, the distance value, there is no direction. It's a directed graph, so 2 to 3 there is no direction, so the distance value I have to take it as infinity. So I will take 6 plus infinity, comma. So now this 2 is over, 3 is my current one. Then I have to take from 4, the distance from 4 I have to write. So this is my current node which I am doing, calculating the distance. So from 4, again the previous value of 4 from the just previous row, that is 5. So 5 plus then 4 to 3, what is the distance? I had to find it out from the graph. 4 to node 3, the distance is minus 2. So that distance I will write is here 5 plus minus 2, that I have written. Then now the fourth node is over. Now I will take from fifth vertex. So this fifth vertex previous value is infinity. Once one value is infinity means we need not plus or minus. Here also from sixth vertex also it is infinity. So I will write it as infinity. Then from the sixth vertex also it is, sixth and seventh also it is infinity. So I will write it as infinity. So here the minimum value from all this is 5 minus 2, that is 3. So now I have filled this one, I have filled now. That is node, this cell I have completed, this cell. So now I have to go for the next cell, that is, now I have to fill this value, I have to get this value, I have to get. So this value, so my current node now is node 5. So how, same procedure I have to repeat. So how I will write for node 5? Node 5, if I write, this is the equation for node 5, distance 5, k value is 2. This is the equation for node 5. Sorry, this is node 4 I have put. This is my current node, node 5 I have to take. So this is node 5. Now I have to write for node 5. That means this cell I have to fill now. This cell, how I will write? Just previous value. So this is the one I have to fill now. Minimum value. Distance to 5. So previous value of the current node, that is infinity. Previous value I will get from just previous row, that is infinity. That value is infinity. So I have written that value here. Then from all the remaining nodes I have to write the distance. So first I will go for the node 1. Node 1, what is the previous value? Previous value, just previous row I will get it as 0. So that is 0 plus, then 1 to node 1 to my current node is 5. 1 to 5, what is the distance? There is no direct distance, so that is infinity. So I will write it as 0 plus infinity. So from 1 it is over. Now I will go for 2. From 2 I will take 2, the previous value, previous row value is 6. So that I will write here 6. Then from node 2 to my current node 5, what is the distance? This is node 2, current node is 5, the distance is minus 1. So that I will write here node 2 to, so this I will get 6 minus 1. Next I have to write from, so node 2 is over, node 3. Node 3, previous row value is 5. So I have written that previous row value 5. Then plus node 3 to my 5, what is the distance? Node 3 to 5, the distance is 1. So that 1, this plus 1, I will write here, plus 1. So node 3 is over. Now other node is node 4. Node 4, previous row value is 5. So that 5 plus node 4 to current node 5, what is the distance? Node 4 is here, 5 is here. There is no direct distance, so it is infinity. So 5 plus infinity, I'll write. Node 4 is over. This is my current node. Then 6 and 7 also I had to write. So 6, what is the previous value? Previous value is infinity. So 6, the previous value is infinity, plus then infinity plus from current node is 5. 5 to 6, again that is 5 to 6 also direct distance infinity. So we need not write, only infinity you can write. From 7 also, from node 7, what is the previous value is infinity. So I will write it as infinity only. So from this the minimum value is 5. So that minimum value I will write in this column, that is 5. Minimum value I have written. So I have finished with the for the vertex 5. Then I had to take and now and again, so this cell is finished. Now I had to fill this cell 4. So filling this cell, this value, how I had to write. So now this is my current node. This current node previous value first I had to write. So now I am filling the 6, distance of 6. This one I am filling. So what all things I had to write? Same procedure I had to repeat. That is current value, previous value of this node. That is previous row value first I will write here. That is infinity. Then from all the remaining vertices from 1, 2, 3, 4, 5 and 7, their how I will write is their previous row value plus the distance from that node to the current node. That value, that distance from that node to the current node value only we have to find from the graph. So how I am getting this, how I will fill this row, that again we can see. So here the distance from this previous current row, current vertex 6, that previous value I have written it as infinity. Then next is from 1, from vertex 1, previous row value is 0. So 0 plus 1 to 6. What is the value that distance that I had to write from the graph? 1. This is node 1. Node 6 is this one. No direct distance. So that value is infinity. So 0 plus infinity I have got. So from 1, vertex 1 I have considered. Now I will go for vertex 2. Vertex 2, currently I am filling this row. So previous row value for vertex 2 is 6. So the 6 plus then vertex 2 to current vertex 6. 2 to 6, there is no direct distance, so it is infinity. I have written. Then 2 is over, then take the all the remaining vertices I have to take. So next I will go for 3. 3, vertex 3. So vertex 3, the previous row value is 5. So that I have written 5 plus from vertex 3 to current vertex 6, what is the value? From the graph I have to check. Vertex 3 to vertex 6, there is no direct distance, so that value also becomes infinity. So 5 plus infinity. Now vertex 3 is over. Now I will go for vertex 4. Vertex 4, previous row value is 5. So 5 plus then vertex 4 to current vertex 6. Vertex 4 is this one, vertex 6 is this one. So the distance value is minus 1. So 5 plus minus 1. Then vertex, that value I have written. Then fourth vertex is over. Next, now vertex 5. Vertex 5, previous row value is infinity. So the sum also will becomes infinity. Vertex 7 also it is infinity. So the minimum value here is 4. So I will get the value 4. That 4 value I have written here. Like that I will be filling the other remaining cells. Row wise I had, after completing this row, then I will start from here. This row I had to fill. Using the same procedure I will be filling all the remaining values. For the third row k value is 3. So third row again I had to fill like the distance 3 to 3, 3, 3, 4, 3, 5, like this will continuously fill those values till we had to write this up to k value 6. distance value 6. We'll get the last final values we'll get over here.